Cool. Hopefully you can all see my screen all right. So I'm presenting for the breed comparison team today, sort of in Dr. Estelle's spot. And I'll mostly just be talking about some of the progress we've made over the last year, particularly at the college ranch, and then I'll kind of fill in, some of the stuff that's happening in Clayton as well. So here's our 4 study sites at the college ranch, which is, as most of you know, about 30 miles north of, or not even north of Las Cruces. And so these are 4 long-term pastures that we've been monitoring for almost 30 years. And so we've been able to map the ecological states and sites so that we can look at cattle use as it relates to all different vegetation use through time. And so earlier this spring, as most of you know, we were successful in deploying our LoRaWAN GPS tracking system. And so we were able to track about 42 cows over the course of almost 4 months, from March into June. And so here in the bottom right corner, you can see some of our Ramari Criollo girls with their GPS collars on. And here you can see how they were stratified across the different sample pastures. And so the little GPS locations there are individual fixes, basically 15 minutes to a half hour intervals of all the different cows over that entire 3 to 4 month period. And basically each one of these pastures is about 2,500 acres in size. So the whole study area is about 10,000 acres. So it gives you a little bit of understanding of the magnitude of the landscape that we're looking at. And so over the last couple of years, we've been monitoring the vegetation annually, both for production in biomass, as well as the percent cover. So we're collecting line point intercept data, as well as several other types of vegetation monitoring, which is occurring. But basically, this is this illustration is just to show you that we have some baseline information, and some of our data from this year is starting to roll in. And I think something sort of integral to note here is that we've had this really bad drought this year. The crop season precipitation was incredibly low, basically less than 1.5 inches. And so the entire research herd has basically been translocated to the NMSU Clayton site, as you guys saw this morning. And so fortunately that little bit of transhumance has hopefully saved some of our rangeland here in Las Cruces. And yeah, the cover is just to show you that we've been collecting this data all along. And so we have sort of baseline data with no grazing for the last few years, and then grazing data sort of moving forward into this year. And so when the cows were in the pastures earlier this spring, here's a photograph of some of the black grama dominated sites, which is our primary forage species here in the Chihuahuan Desert. And so you can see where some of the animals were grazing, and these areas were monitored very closely over the course of that trial period, as you can see. So we went out to key grazing areas that we know that the cattle like to graze in because of an abundance of those super palatable forage species. And so at various intervals, we were monitoring the stubble height, which is the amount that's actually grazed off of the plant. And here you can see that they're sort of varying over time, but sort of decreasing in each circumstance. And as soon as one of the pastures got to our critical height of about 8 inches, everything was destocked. And so that's how we were able to maintain sort of a rigorous analysis of stocking rate capacity. And so here's some of the preliminary production data on the cattle side. Basically all summer, myself and Andrew were measuring lick tub use per pasture. And so what we found was that the Criollo tended to consume less high protein supplement, which was being provided to them, both on a per head basis and on a kilogram per kilogram basis. So this has some potential implications for both the breed comparison team and possibly the supply chain options group because there might be some money savings advantages in the Criollo here. We also track their body condition scores through time. And so this is something we can get into later, but you can see that they changed possibly in relation to both plant availability and then the animal's own physiological state, because all these cows were calving during this time. And then here you can see some of the first data of its kind, I suppose, where we were able to look at the calving weights and the cow weights between the biotype groups. And so here, for instance, the beginning weights of the animals were different, obviously. So were the end weight changes. But what's sort of interesting is that the percent body weight change was statistically not different. So both groups of animals basically gained weight across the course of our grazing study. And of course, their average daily gains were different too, just because of those differences in their morphological sizes. And regarding the calves, and here's a couple of the crossbred calves. These were sired by Rangus bulls and our Criollo cows at the college ranch. And the birth weights were actually fairly similar. They're around 30 kilograms, which I think is fairly typical of desert calves and beef calves in general. And you can see that there was an advantage in the percent of the cow's weight that was born per calf, where the Criollo calves were essentially birthing larger calves compared to their own body size. Here we can see that the calves were weaned at about 180 days, and there was a difference in those preliminary weaned calf weights, where the Criollo Brangus crossbred calves were a little bit smaller than the Brangus calves, which I think is probably emblematic again of our super horrible drought situation in the Chihuahuan Desert this year. But ultimately, what I think is sort of interesting is that the weaning weights as percentage of the cow's weights were not different. And so in both instances, the Brangus and the Criollo cows were able to wean about 40% of their body weight. And this is, I think, also fairly typical of what you see in sort of bad drought years, where the cow's efficiency is a little bit depressed, as opposed to possibly wetter years where you might have 50% of the cow's body weight being weaned in pounds of calves. And so basically all the calves from the college ranch, as well as the Utah site and the Corte Madera, all were sent to Clayton earlier in the month. Is that right, Dr. Duff? And so I think you guys have received about 120 calves
yes.
total.
Yes.
And so now you guys are sort of taking over that end of the spectrum, beginning to track the calves' weight gains and potentially their behavior as well. The LoRaWAN system has been moved up to Clayton alongside the research cows. And so that gives us potential to possibly track the calves as well. And Dr. Cibils might get more into that in the precision ranching updates. But yeah, I think we were successful in collecting a considerable amount of data this year. And here's sort of just an overview of what we did.
Thank you, Matt. So we might take is there one quick question of clarification, or we'll have time after everyone's spoken for discussion, but if I don't see anyone. Okay, so thanks very much, Matt. We'll go on to the precision ranching update from Dr. Andres Cibils.
Okay, can you hear me and see my screen? Is everything okay?
Yes, sir.
All righty. Cool. So I'm going to provide this update on behalf of the team, and this is good. And this is the team. This is our core team. It has grown a little bit this year. So Laura Boucheron and Weeping Cow and Andrew Cox, Rick Estelle, Shishu Gong, John Holland, Matt Macintosh, Shelemiya Nyamurikunge, and Tony Waterhouse. And so I'll talk a little bit about team growth in a minute. I thought I'd start off with just providing a refresher of what our task is, what we said in the proposal that we were going to do as far as precision ranching in this proposal. And so our goal, our task is to develop a precision ranching system and evaluate its impact on ranch input costs. That's what we're aiming to do. And basically this has three parts here. We want to deploy and test precision technologies that are able to log, transmit, and analyze sensor data in real time. Then develop a ranch dashboard that will display the sensor data. And finally, determine whether all of this can increase operation efficiency and lower production costs. So this year, we spent most of our time focused on number one, trying to get the system to work and trying to collect the data and learn about the technology and how to use it. And so anyhow, a lot of my presentation will have to do with that. And hopefully this of course is a 5-year project. So in presentations in years to come, we will be talking more about the specific objectives 2 and 3 here. So these are, I think, and I'd ask here that if any of the team members has anything to add or disagrees, just please unmute yourself and jump in. That's absolutely fine. These were, in my mind, the 5 things that we accomplished this year that were important. We expanded our team with grad students. Huiying Chen is a new PhD student in computer science. Zach Winkler, who was with us earlier today, is a master's student in engineering. We were lucky to recruit Tony Spence, who's an engineer that specializes in radio communications. That was very, very helpful and continues to be very helpful in helping us understand the technology and carefully pick the best components that I'll talk about in a minute. And Shelemiya, who you saw on the title slide, previously helped us as a grad student, has since graduated and has now joined our team as a postdoc. And so we are proud and lucky to have these sharp minds working with us. So the other thing we did was tested the LoRaWAN system at CDRC, and Matt covered that a little bit. I'm going to come back to that in a minute. So I won't go into too much detail. The only thing I'd mention is that besides collecting the data, we were able to set up a protocol to automate data retrieval from the cloud, store it on a server in the College of Ag, and do some preliminary data analytics, very, very preliminary. But that is a big feat, because of course getting the data is important and took a lot of effort, and continues to take a lot of effort. But then getting the data somewhere where we can access it and having data analytics automated is very important to the next steps of this system. We spent a lot of time evaluating equipment and purchasing equipment. We now have most of the equipment we need to expand out to the cooperating ranches on the system in the project. I'll talk a bit about that in a minute. One thing we did, and this has come up in a number of conversations in the extension, the on-ranch demonstration earlier today, and Matt mentioned it as well, is that we expanded the scope of our project as well, adding the Clayton Livestock Research Center. A lot of the cows that we were monitoring here in Las Cruces went up there. So thanks to Shelemiya's quick reaction here, and to the expert help of Micah Funk, who is not a part of this team, but we all, as you realize, wear different hats, and there's a lot of cooperation across teams. And so Micah and Danielle, although I didn't mention them, are of course important contributors to our efforts. So we installed the LoRa system in Clayton, and hoping to do some work there. Glenn mentioned this morning some of the questions we hope to address, but something else that we are hoping to do is to do some calibration to pair our data with on-the-ground observations and come up with better algorithms to classify behaviors and so on. Anyhow, I won't bore you with the details. We've also added a new technology that wasn't in the original proposal, given the expertise we have in Dr. Laura Boucheron and Zach Winkler, and that is we're hoping to use 3D imaging to set up an automated system to track body condition score. And so they're going to start working on that as well, and hopefully we'll have more to report about that next year. And then we, of course, communicated our work, posters, presentations, webinars, and refereed publications as well. So most of what I'm going to talk about, I probably have, I don't know, Jean, 2-3 minutes left or something like that.
Not really.
Oh, less?
Wrap it up if you could. And you've been talking 6.5 minutes.
Oh my God. Okay. All right. Sorry about that. Okay. So I won't show you anything else then. I will just say that most of what we concentrated on this year was testing the LoRaWAN system at CDLC. If I've got 30 seconds, this is just a graphic of what the system consists of. These are the components of the system. I'm happy to share my slides, talk about them. It's purchasing the sensors, but mounting them on the cars and configuring them is quite a deal. Matt showed you some of this. We've tested the gateway and its capabilities. This is the data that we are storing on the NMSU server and some very preliminary analytics. This is where we're going next year. We're going to move out to the green stars, at least to 3 of them. And we're going to start working on more sophisticated data analytics and begin working on the dashboard. This is our dashboard today. I won't go into details, but we want to integrate this into a single dashboard. Thank you. Sorry for taking more time, Jean. I'm a South American and I can't stick to 5 minutes. So thanks.
That's fine, Andres. I think really the questions moving to the end of the session will be fine because all of the different presentations probably are going to touch on interactive issues as well. So our next update will be from Sheri Spiegal, the supply chain options.
Andres, that was an amazing wrap up. First of all, just kudos to you. Incredible. Okay, hi everyone. So the supply chain options team is a multidisciplinary, multi-talented team that has met once a month for the past year. And if I can only advance my slide, I could, hang on. One of our primary focus has been defining the key components of U.S. beef supply chains, from inputs to production all the way through to the consumer purchases. And a primary principle underlying our work is that U.S. beef supply chains, especially when they include rangeland production, are really geographically extensive. So you can have one part of the supply chain in one region, another in another region, and yet another in another region. So in this example, we have cow-calf ranching in the Southwest, where a lot of the calves are exported to the Southern High Plains for feedlot finishing, as we learned about earlier today in our extension, in our fabulous extension activity. And then in this supply chain example, corn that originates in the upper Midwest or in the Corn Belt is actually exported from the upper Midwest to the Southern High Plains for that feeding and finishing. One thing I learned this morning is that you should always recheck your assumptions about supply chains and their complexities, because as Dr. Duff explained, a lot of the corn is actually produced locally. So Glenn, we will be looking closer into that. But the key here is that we have geographically extensive supply chains in the US. And so with these principles in mind, we have defined 7 supply chains over the past year, all of them originating on rangeland in the Southwest, and all of them originating with cow-calf ranching in the Southwest. And so we've defined these 7 chains. One of them is really the business as usual conventional supply chain that is really prevalent, which is Angus, so cow-calf ranching in the Southwest with Angus genetics, calves exported to the southern high plains for finishing. Those calves are slaughtered by bigger packers and then nationally distributed. Alternative supply chains that we're looking at have tweaks in that system. So differences in genetics, including heritage genetics, and grass finishing is another tweak in that system, both in the Southwest and in the Northern Plains we're looking at. We're also thinking about manure shed type management or increased manure recycling from feedlots. And so part of our focus is really looking at kind of the state of the world or the state of the Southwest under 2 different sort of states of affairs. So we're thinking about a current state of affairs where this one supply chain is prevalent, and a future state of affairs where all 7 might be prevalent and the number of cattle going through the chains is more balanced. And so to really assess the sustainability of these 2 different states of affairs, the current business as usual versus a future potentially more sustainable. So we're using a coupling framework with the idea that systems within systems are all connected. And so looking at one region where beef production occurs, this is called intra-coupling. So this is an intra meaning within. So we have in each region a human system and a natural system, and they're connected through flows of material and energy. So from the human system to the natural system, a lot of those flows have to do with management. And from the natural system to the human system, it has to do with ecosystem services or material or immaterial benefits that we get from ecosystems. And we're also looking at the causes of those flows, the agents of those flows, or who actually makes those flows happen or manages those flows, and the effects of those flows on human and natural systems. So this is all within one region. Layering on, we can start to look at the different regions that are coupled together through beef production, through these extensive supply chains. So you can see that region we were just looking at in the lower left, and that contains all of the components that I just explained. And then layering on, we can start to see these coupling relationships with other regions. So peri-coupling, so we're looking at the Southwest as peri-coupled with the Southern High Plains because they're right next to each other. And then the Southwest more tele-coupled with the Northern Plains because they're farther apart. And again, that kind of relationship has to do with exporting calves from the Southwest to the Northern Plains for grass finishing. I've included the Upper Midwest here as a spillover system because the idea in this type of framework is that other regions actually have some spillover effects. So what happens with the coupling between the Southwest and the Southern High Plains can affect the Upper Midwest. And so that's shown with those spillover relationships. So another key part of our thinking that we've developed over the past year in our activities is this thinking of the current state of affairs and this future state of affairs, where this current state is that this one supply chain is prevalent and that future one where all 7 are more balanced or there's more of a diversity among them. And starting to do some thinking about what that transition looks like with major external forces and internal forces. But really the example here is climate. Climate can affect this transition from this current state to the future state. Continued social distancing, as we're experiencing now, that we saw a lot of news, and I'm sure a lot of us have experienced the effects of social distancing in the packing plants and what that means for the supply chain, and related outcomes of consumers demanding more local beef. And so looking at those kinds of factors and thinking about what it might take or what would trigger a transition from this current state to the future state. And so as a team, this multi-talented, multidisciplinary team, we are applying our research chops to this problem. We're using qualitative research, quantitative research, empirical models to really understand the flows between the components of these systems, thinking about the current state and the future state. And this week, we're really looking forward to connecting with the extension and education teams to think more about the factors influencing participation in the different supply chains and how participation in the different supply chains might affect this transition from this current state to a hypothetical future state. So we look forward to connecting with you all. And with that, I will pass it back to Jean.
Thank you, Sheri. Excellent update from the supply chain team. And now that would lead us to a report from our extension team, and we've got a team presentation from that team. Emily, Elias, and Craig Gifford are going to do a pass off at some point in this report. And I think Emily is starting. So Emily, we're not hearing you.
Sorry, I think
Craig's starting. Craig, we're not hearing you.
Yes, I'm sorry. I shared screen before I unmuted myself, so that poses a challenge. Okay, so for the extension team update, if everybody can hear me, if not, notify me somehow. But I'm going to go through 2 quick updates and then pass off to Emily for a few more. And before I get started, I'd like to say, though I get to report this, kudos to Sky, who really keeps this going. So Sky's done just a tremendous job and a whole lot of work on all of these. So thanks, Sky. The first thing I think that we really have to report, we had a big launch symposium that was part of the grant, was to initiate a big launch symposium and invite producers. We coupled that with the Southwest Beef Symposium, had approximately 125 attendees. And then we also were able to distribute, one of our initial surveys to look at different interests and barriers to adoption of some of these novel strategies the grant is investigating, which led to a peer-reviewed journal article already. So that was great. And again, Sky had done just a lot of work on these. The other thing that we've been working on, a component of the grant for the extension team, we were supposed to identify breeds in the region, how those breeds are chosen, and what some barriers to adopting new breeds are. So we worked to develop a bull management, and we added calf marketing onto that. We thought while we were doing a large survey, we might as well gather as much information as we can. Our objectives, is fortuitous timing that our objectives align very closely with a group at Cal Poly, Dr. Zach McFarland. And they were asking some of these similar questions. So we adapted their survey and tried to keep a lot of the similar question, or a lot of questions very similar from their survey. And then we tailored a few extras for ours to meet our objective. The benefit to this is that the long-term goal will be sort of a synonymous or unanimous type of survey that we can distribute through the West and then compare data from several different regions. And so when they asked us if we'd be willing to do that, we all agreed that this would be a great collaboration we still accomplish our goals, but also can chip in and help with their project. So far, we had, I think, ballpark 125 responses, but only 77 were complete. Keegan Taylor, I think you've heard him. He's been working on this quite extensively. He's going to give an update on December 7th. If you haven't done so, you can register at nmbeef.nmsu.edu. And I don't want to steal Keegan's thunder too much. I'll just tell you that, it was interesting, similar to the California results. Physical traits seem to be the most prominent selection tool amongst producers. And calving ease was the predominant EPD that was evaluated. Weaning weights were also important, but lesser than those two. And relative to the grant, most producers indicated that drought and breed adaptability were important in their decisions in breed selection. So there's a whole lot more information that's going to come out of this. But again, I don't want to steal Keegan's thunder. So log in on December 7th and you can get that full update. And with that, I'm going to pitch it off to Emily.
All right, thanks, Craig. And I was just thinking how great it is that we're such a collaborative team. So we meet and we have a meeting for this whole year every 2 weeks. Glenda and Craig and myself and Sky and Rihanna and Corey Dorn and Brent Oberman often joins us. So, and this is an open meeting. So if you have some ideas that relate to knowledge co-production or this idea of understanding what producers need and how that feeds into research and then how research then feeds back to the producers, then that's the space we're operating in. And one of the components of the grant, as it was originally written, was really to get a deeper understanding of grass-fed beef production through the extension team. And so we reached out to some of you, some of the project team members, also did a web search and identified 90 grass-fed beef producers. And we developed this dynamic web-based map of those grass-fed beef producers. It's online now on the website. And we also decided we wanted to know more from them. And so because Sky was so successful in getting our IRB, our Institutional Review Board approval this year, we were able to modify that and send out a survey to those grass-fed beef producers. They're all coming back in now. And we plan on really sharing some of what we found about some of the components of the operations, where they're located, via peer-reviewed publication. We're also going to send a summary back to the producers themselves, so they're included in, knowing the landscape of grass-fed beef production. And then this will also be one small component of the eventual sustainable Southwest Beef Knowledge System. It's a mouthful, but it used to be Western Beef Knowledge System, and I think we've changed that to Southwest Beef Knowledge System now, but Sheri will tell us more about that tomorrow. Next slide, please. We also took a deeper dive into decision support tools, right? So this Western or Southwestern Beef Knowledge System is to help folks make decisions, but we wanted to understand the depth and breadth of what's already out there. And so Corey Dorn, who recently completed his master's, is a geographer, and he has been searching, and he's located and documented, I think even a few more than 280 decision support tools already out there associated with the cattle industry. He's also reviewed 60 peer-reviewed articles. And we're going to create a searchable tool shed that's part of the Southwestern Beef Knowledge System that links those tools that are already available with the questions that people are needing to answer, so that it's not just this huge, complicated landscape, but really is part of displaying what's already out there. And that will help us share and create what's novel in this project. And there's certainly a lot of novel things here, but understanding what's already available is a piece of that. There's ongoing research into some user preferences for decision support tools, and then Corey will present some of his findings at the SRM virtual meeting in 2021. Next slide, please. And so we've been pretty creative. COVID has necessarily pushed us into thinking about other ways of connecting with each other. Those of you who attended the virtual on-ranch demo today experienced one of those. But we have also made some good use of webinars. We've used some traditional outreach in fact sheets. We also launched a podcast, and we just recently interviewed Andreas for another update on the project in our podcast that will be aired next month. Sky's done a great job with social media, and so if you're not following the Sustainable Southwest Beef Project on Twitter, that's available. Sky does a great job there. we've developed some case studies around heritage genetics and spread them out in other places, like through the Bureau of Reclamation, other ways of reaching people. And then we have 3 short videos that were part of the Jornada Symposium about components of the project. So I think the high points this year are that it's just been a delight to work with the extension team. It's been a really fun team to work with, and I think that comes out. I'm really thankful for getting through the IRB process, for administering those 2 surveys this year that are informing some outreach and peer-reviewed publications. And then doing some new novel things related to outreach. And then finally, just continuing on that knowledge co-production piece of trying to understand what ranchers really need and how that feeds into the research and vice versa. And with that, Craig, did you have anything else you wanted to add?
No, I think we got that covered, and no, absolutely, just a great group to work with. And I'm going to stop sharing. Whoops, maybe stop sharing.
And a very busy group. Thank you very much, Craig and Emily. That was a great update. Okay, our next, I think we'll move on to our education partners, and we're going to start off hearing from Stephanie Bestelmeyer about the Sambro Institute.
Great, thank you, Jean. All right, so I'm going to be presenting about the Sambro Institute's component of the education, K-12 education team, and then you'll hear from Christy and Anne right after this with what they're doing out at Bluestem. And I'm going to use the word we a lot, and really, I mean mostly Amelia Lindley, who a lot of you have had an opportunity to work with over the last year. So I'm presenting, but a lot of this is Amelia's very hard work. So really, we had 2 objectives that were written into the proposal, and it goes back, of course, to this wonderful graphic. And really, we live over here in the left side in this education box. And from the very start, the intention was twofold. It was first to take all of the knowledge being produced, both from the research and really from, to a lesser extent, but from the extension teams, and use that to increase K-12 students' science literacy, and especially their knowledge about technology and agriculture and novel strategies for sustainable beef production. But we also, from the very start, said that it was really important to recognize that the audiences that we work with within this education box are very soon going to be the future ranchers, the future consumers, and the future people, land managers and others who are going to be making decisions. So it's really important also to take their information and their thoughts and feed that back into both the research and the extension team. So it's very intentional that the arrows go 2 ways on this graphic. So how did we propose we were going to do that? We said in the proposal that over the course of the 5-year project, we would be designing and delivering 10 hands-on lessons. And we wanted them to be very flexible so they could be used in classrooms, after-school programs, 4-H clubs, and other venues. And I think it often surprises people to learn what it takes to go from kind of a harebrained idea to a full lesson. And it's a very extensive 15-step development process that we go through. And it includes pilot tests, it includes lots of revisions based on those pilot tests with students and reviews by both educators and scientists. We also have the intention of doing at least 5 educator workshops to disseminate these new lessons and promote their widespread use well beyond the end of this 5-year project. So in year 1, you know, I'm really just delighted by what we've been able to accomplish, especially given the complication of schools having been closed since March 13th in our region. So we have a start or a completion on 8 education lessons. And you'll notice that they go all the way from first graders who actually get to see a little animated Andres and they get to actually see some of the movement data from the GPS tracking, similar to that image that Matt showed earlier. And they go all the way through high school students. And we very intentionally want to kind of really make lessons that span that gamut from 5 and 6 year olds all the way until high school students. The second column here shows the status, and development, or the D, means that it's in development. And most of these are very far along in the development phase, and quite a few of them are just ready for pilot testing as soon as we're able to get back into schools face-to-face with kiddos. You'll notice a few of them are in the implementation, marked with the I, which shows that they are already underway. We've actually already gone through the process and been using them with students. We also have been very intentional about trying to make sure by the end of the project that we have lessons that cover the 3 major research themes of the project: the heritage genetics, precision tools, and supply chain. And you'll notice that quite a few of the ones we started with were criollo, because we already had a lot of research that we could base those on. We've started delving a lot more into the precision tools with great help from all of the scientists and especially graduate students who've been working on these projects. And then we're just starting to delve into supply chain options as well for some of the lessons. I will mention this, the Solving the Beef card game is listed for middle school and high school, but you'll all have an opportunity to play that with Amelia. I believe it's tomorrow. And that is a game that certainly could be fun for the whole family. So our plans as we move forward from here, or what we've done so far, I guess, is we have done direct delivery of our lessons to 152 students so far. Again, this was greatly curtailed due to school closures in March. And then we made that Solving the Beef game, turned it around and made it available online very quickly as something that FFA teachers could assign to their students who were suddenly learning from home. As we move forward into 2021, we want to finish the development of those so that by the end of the second year, we'll actually have 8 of our total of 10 lessons already developed and in the implementation phase. And we want to do at least two educator workshops in 2021. And we now have the capacity to do virtual workshops and on-demand videos and other ways to interact with educators. So while we would love to do an in-person workshop, if it's not possible, we'll still be able to interact with teachers and other educators. There's our animated Andres, if anybody's interested. And I think that is it for me. I'd be happy to answer additional questions later on in this session or anytime during the next couple of days.
Great, thanks, Steph. Let's go ahead and move to the update from the Bluestem Agri-Learning Center, and Christy Ehlers and Ann Marshall are going to team present. I'm not sure which one's starting.
Well, I'm going to start and probably do most of it. I'm Christy, because we also are having a class right now. And so we have students, we have students who are here virtually, actually, we have students, and they're doing a lesson in some things with aquaponics. But Bluestem is, we're kind of an outlier. We're in El Reno, Oklahoma, which is central Oklahoma. Our role in the grant project was to develop lesson plans related to state sustainable food sources and farming. And we're testing those lesson plans out right now with our students who come to us, who are, they're not just randomly assigned to us. They have to apply to the program and be interested in agriculture in all STEM areas. And so we have high school students from 3 different area high schools who are doing research on various types of sustainable food sources and farming. And so we have designed opportunities, or are designing them, for students to research various methods and strategies for continuing agriculture in the 21st century. When Sky posted the question earlier about how beef production would be sustainable, my biggest concern from where we are is that we make sure and empower our upcoming generation so that some of those little entitled folks learn that they're going to have to be responsible for finding green places to have gardens and finding places, what does in this case COVID, how has it impacted the beef production? And we have one of our students whose father owns a feedlot, and so we're looking at the types of things that he's facing right now. And then we are utilizing a farm bot or two farm bots actually, an aquaponic system and conventional, that should say convention, not convention, conventional gardens to compare and contrast different types of growing systems. So this is an idea, these are not ours. I have so many photos, these are stock photos, but just to give you an idea, we have a farm bot that we have planted. Well, first of all, you have to build this thing, and then we have planted various things here. Actually, the farm bot using this robotic arm right here has planted the seeds for these. Then all of this is done through a game-like app on your phone. So we tell the farm bot to pick up the seeds for radishes or dill or carrots or any number of things and plant them. And then the farm bot knows that this plant is here and what it is. And so it will change its head right here to watering, a watering spout. And this is connected to water. And so it will water this plant and will water all plants according to its need. If the farm bot, which also has a camera on it, sees that there is something growing that was not part of the plan, the farm bot thinks it's a weed, and so it will eradicate the weed. And then using the camera, the farm bot can send us information saying, your produce is ready to pick. And so we are not at the produce ready to pick stage. We had some complications with our outdoor farm bot, and now we have one that will be similar to this that is indoors in our basement. And next door in our basement, I might just add, we're in a house that's 150 years old, that's been remodeled. We're on government property at Fort Reno. So we kind of have to utilize whatever space we have. And we can't build a greenhouse or anything on the land because we don't own the land. But we have put, and again, this is a stock photo, but we have put a 2-bed farm bot system in. And actually ours under here has our fish tank. And so we have some big goldfish who are feeding here. We feed them, and then the water comes up through these places right here, and it fills the bed. What's in the bed is not pea gravel or rock or soil. It is specifically a grow medium that was designed for aquaponic systems, and it retains some of the water. So this is going 24 hours where this will fill up with water. And then when this bell siphon, which is right here, when it gets to its max, then the water drains and goes back into the fish tank, which is here. And so it's constantly flowing. And we have planted lots of crops here. Because we're indoors, we have some artificial, pretty fancy lighting, and a picture I'm going to show you in a minute. You'll see it kind of makes everything look like pink, but it's not really. But then these are examples of some of the types of posters that our students will design. This was actually done before we got on the grant project, but we were looking at conventional and no-till soils under some different fertilizer rates. We're talking about water quality, and then this one is talking about the effect of fertilizer on biomass. So that's the kind of things that our students are getting ready to produce. This picture was taken during this presentation, and you see this looks pink, but that's because the light that's over it, some kind of magic grow light. I wish I could be more specific, but we have planted carrots and spinach and tomatoes and dill and lavender and a couple of other things. But we are growing, we're also going to plant wheat, and we're going to do this in our farm bot system. But if you look really closely, we planted this last week. So if you looked really closely, there's a little green sprout there, and there's a little green sprout right there. And so we're going to grow some wheat in the aquaponics system, in our conventional garden, and in our farm bot, and compare grow rates and what we need, what would be needed. Obviously, this is not going to be enough wheat to do, to do anything with, but we're looking at different ways that grow systems work so that we can find out the best thing, best way for food production to occur, or some good options. We're promoting science literacy. Our students are doing all manner of research on the aquaponics system and how it works, on the farm bot and how it works, and on our conventional garden and how it works. We're doing a lot with technology and education, and how can technology, or not education, in education, but in agriculture, and how can technology, because we're so technological, how can it benefit sustainable food sources and enough produce for the growing world population, which is with shrinking places to areas to actually have gardens or fields of wheat or that type of thing. We are also going to do professional development for teachers, and that hasn't happened yet because our school district, the school districts around us, nobody's going anywhere, and they close about every other week, and students go on distance learning because of Oklahoma is not really good with the COVID mask and precautions and that kind of thing. And so we're struggling a little bit with that. But our students have developed some traveling trunks. One about aquaponics. We've got one about bees, because we have bees and that type of thing. So these trunks could be checked out by teachers or civic groups or interested community partners, and they contain lessons at different levels. And so students in a classroom, or if you're talking to a civic group, they can actually do some hands-on types of things. And we are managing this remotely a lot. We can't have all 20 of our students here at the same time because we don't have enough, they're too close. And so students are broken up into small groups, and they're coming to Blue STEM to do the research, but a lot of things we're doing virtually, and we get students prepared for that before they come to us. And that's all I have.
Okay, great. Thanks so much, Christy. Thanks to all of our speakers. Let's, if you find your little reaction button and you can just do some applause, that would be great, because I think all of our speakers did a great job for us. Now we've got time for discussion, and I think there should probably be quite a lot of questions to the specific speakers or comments about something that maybe you heard from one team that may have relevance to another team. So it's just kind of open, and I think I will be, let me pull up the participant list. I'll be looking for raised hands, or if it doesn't get too crazy, we can just let people unmute themselves and pose a question. But if you do that without being called on by name, introduce yourself. So let me see, I've got the participant list. I can't see all the participants at once. So if you're raising your hand, be patient. And in the meanwhile, I did suggest to Karina that if she wanted, and I think it's really a nice little visual that she's got ready for us of all the things that she has been capturing as she has listened this afternoon. And so for somebody who hasn't had a chance to work with this team very long, she just was contacted a week or so ago about working with us on this meeting. She's getting a lot of our key ideas and connections starting to show up here on the drawing. So thank you, Karina.
Yeah, can you see that large? Is the screen share working? Yeah, okay, great.
Yes, it's perfect. It's perfect.